Alright, today what we're going to do is we're going to use similar triangles to try to solve pieces of a triangle. So let's say we have two triangles. Let's call this ABC, and let's call this DEF. Let's call this 3. We don't know what that angle is, but that's congruent to that. And this is 7, and this is 4. And let's say we know for a fact that triangle ABC is similar to triangle DEF. Now what that means is that AB has to be proportional to DE. BC has to be proportional to EF. And proportional means that their ratios are very similar. So if I were to put some unknown value there and I wanted to figure out what this is, what I could do is I can say, well, AB to DE, what would that be? That would be x to 7. So x to 7, whatever that is equal to BC to EF, so 4 to 3. So 4 to 3. And then what I have here is a proportion. In a proportion, when you have a fraction equal to another fraction, you can actually cross multiply, which means multiply diagonally and then set them equal to each other. So if I multiply 3 and x together, I get 3x. And I set that equal to these two multiplied together, which is 7 times 4, which is 28. What that means is that if I were to divide both sides by 3, I can actually solve for x, and x is actually 28 thirds. Okay, so this works anytime you have similar triangles. Now, I was given that these are similar, so for the next couple of examples, I'm going to give you that they're similar. So if I have triangle, I'm going to go back to my favorite, POL, and triangle ICE. And I know for a fact that triangle POL is similar to triangle ICE. And I know that this is 5, this is 2, this is 8, this is 4. What I can do is I can actually solve for both this thing and this thing. X and Y. Okay. So first I'm going to set up that the 5 to 8, right? PL to IE, PL to IE, 5 to 8. 5 to 8 is equal to 2 to, we don't know, we'll call that Y. Also, I can say that PL to IE, 5 to 8, is also equal to x to 4. In both cases, I can solve for x and y. So when we cross multiply here, we're going to get 5y equals 16. And then we get y is equal to 16 over 5. And that's my answer. Here, if we cross multiply, we'll get 20 is equal to 8x. If we divide by 8, we get 20 over 8 is equal to x, and we can actually simplify that. Take out a 4 from both of them, we get 5 over 2. So it turns out that y is 16/5 and x is 5/2. And that's how you can solve for missing side lengths if you have two similar triangles.